In this tutorial video, we're basically going to look at exponential functions. So before you dive deep into exponential functions, I would love you guys to be conversant with this word, an exponent. What is an exponent? You need to have more knowledge on it. An exponent is basically showing you how many times a base can be multiplied by itself, or rather how many times a number can be multiplied by itself. This means that if that's a definition, if we have got 3 to the power 2, then we say 2 is our exponent, then 3 is the base. By definition, we are saying 2, which is an exponent, is showing me how many times 3 must be multiplied by itself. So basically, this is going to be 3 by, that's 1. So now, what if we are told now to say evaluate? If we are taught to evaluate, or in the first place 3 to the power 2, we are given 3 to the power 2 to evaluate it, it's more like they're telling us to find the exact value of 3 to the power 2. How can you handle such a situation or such a question? Since you have already expressed this, you have already interpreted to say 3 must be multiplied by itself 3 times, just try to find the answer. What is 3 by 3? Which is definitely 9. So this is the exact value that stands for the evaluation of 3 to the power 2. Alright, let's try to put another question. When they say 2 to the power negative 3, they say evaluate. Evaluate. By now you understand to say to evaluate is to find the exact value, right? Yeah, hope everyone is paying attention. If you've got a question, you can just easily raise your hand, then I'll be able to see it. Then we'll tackle it. Okay, so now 2 to the power negative 3. 2 to the power negative 3, the first thing that you need to understand is that is not a positive index. So you need to first change this negative exponent to a positive. How do you handle such a thing? It's by basically using a 1. So when you introduce a 1, meaning the negative has gone. So what is the answer? This is 1 over, what is 2 to the power 3? That's an 8. Like that, it means that you have solved it. So if you have been taught to evaluate a negative index, the first thing that you're supposed to do is to first follow this step, which is expressing the negative index to a positive index. Then secondly, you now proceed with the evaluation, which is just basically finding the exact value. All right, let's move to the next step. The next step, we just want to see if you've been told to add similar bases, and if you have been told to multiply similar bases, or rather you have been told to add, or you have been told to multiply or to divide similar bases or to subtract, what is it that you're supposed to do to the exponents? Let's try to see that one. Let's try first to perform addition. Addition, the rules that you're supposed to follow. If they tell me to say 3 to the power 2 are added to 3, if you look at this, you will realize to say able to appreciate the exponent, but here we are unable to appreciate the exponent. If you are unable to see the exponent on a number, it means that the exponent is basically 1. When you've got an exponent that is greater than 1, that's the reason why you are seeing 2, 3, 4, and the like. So implying that this is equal to, the first thing that you're going to do is you're going to first since when you're adding similar bases, of which these are similar bases, these two are similar bases, addition of similar bases, just multiply the powers. So when you're performing addition, multiply the powers of similar bases. Okay, so this is basically 3 to the power 2 multiplied by 1, which is definitely going to give you 2 by 1, that's a 2, which is 3 to the power 2, which is definitely 3 to the power 2, that's a 9. Good. So like that, it means that you have found the exact value if you are told to evaluate. If you are told to evaluate. What if you're performing multiplication, just to the vice versa? Similar, when you have got similar bases and you're told to multiply, just add the powers. Then that's it. Maybe let's give an example on that. If I've been given 3 to the power 2, multiplied by 3 to the power 1, this is equal to This is 3. Since you're multiplying similar bases, just say this is 2 plus 1. Since it's saying when you're multiplying, you add the what? You add the powers. You add the powers. So this is going to be 3 to the power 3, which is definitely going to give you what? A 27. Like that. Means that you are okay. Okay, now let's move to subtraction and division. If you are dividing similar bases, they give us 3 to the power 6 divided by 3 to the power 4. So meaning our exponents that we are dealing with are basically 6 and 4. We are saying if you have been given similar bases where you have been told to divide them, the first thing you need to do is you need to subtract the exponents. So this is 3 to the power 6 minus 4, which is eventually going to give us 6 minus 4. That is 3 to the power 2. What is 3 to the power 2? That's a 9. Like that means that you're done. If you have been told to subtract, similar bases, just basically divide the powers. Let me maybe give that an example on that. So if you've been told to say 3 to the power, maybe they say this is 4 minus 3 to the power 2. We can easily say, let me first cut here so that there's a division. There's a division of the questions. Yeah. So like there's a separation. Sorry. This is 3 to the power. If you do that, that is 4 divided by 2. Since these are similar bases, this base and that base are similar, and you've been told you have to subtract them. What do you do to the powers? You divide the powers. So this is going to be 4 divided by 2, which is going to give you 3 to the power 2, which is equals to, because 4 divided by 2 is basically 2. So 3 to the power 2, it's a 9. Like that, it means that if you're capable of applying these rules, you're good to go. But there are situations where you're supposed to apply these rules, but you're unable to see. Let's try to see that one. Let's try to use subtraction. But this time around, it's more like we want to explain we want to see them in an equation. They give us to say 3 to the power x, give us 3 to the power x uh, minus 3 to the power 2 is equals to 9. Yeah. So we know to say when we add 3 to the power 4 minus 3 to the power 2, that gave us 9, right? But this time around, how can you handle such a thing? There is a rule. When you're dealing with equations, the first thing that you're supposed to do is you need to make sure that the bases are the same. So we know that we already have 3 to the power x minus 3 to the power 2. But how can you write 9 in terms of 3? We know that 9 is as good as writing 3 to the power 2. 3 to the power 2 is the same as 9, isn't it? Yeah, since now the bases are the same, we can now say on this part, since the bases are the same, what do we do to the powers? We are supposed to divide the powers. Since we have got that, we are supposed to divide the powers, which is x divided by 2. Then we know that that is equals to 2. We have just gotten these powers like that. We've gotten them, but we know that here there is an existence of subtraction of similar bases, of which that is the same thing that we were doing here. That's the same thing that we were doing here. And what did we do to the powers? We divided the powers. That's exactly what we are doing here. So we are supposed to be able to apply. It looked like we are dealing with high school stuff, but now it's more like trying to advance. I think even this one is high school. So now x divided by 2. We know that x divided by 2 is as good as writing it as x over 2, which is equivalent to 2. Then you can do your cross multiplication. After you are done with your cross multiplication, I say that your x is equals to 2 by 2, that's a 4. And definitely, that's what we were looking for. Yeah, now let's try to see how we can handle a situation where we have got a negative exponent. In short, most of the times, let me first try to bring in another question that we are going to relate to more. At first, we said when you have been given 2 to the power negative 3 and you have been told to evaluate, the first thing that you're supposed to do is to introduce a 1 in order for you to get rid of a negative, isn't it? this is going to exist as 2 to the power 3, right? Then eventually this is going to be 1 over 2 to the power 1 over let me just erase that one. If I've been taught to evaluate, it means that 2 to the power 3 is basically what? 8. But if you are capable of doing this, examiners want to find out if at all you understood your work better. How are they going to find out on that one? They're going to bring an equation of indices. They're going to bring an equation, and in that equation they'll tell you to find x, which is 2 to the power. They'll just say 2 to the power 2 to the power x is equals to 1 over 8. They say find x. And you know, each time people look at a question or meet a question that they have never seen before, they always feel like they can never solve it. But now, just try to think a little bit. So you see, we have got 2 to the power x equals to 1 over 8. The first thing I said is, when you're handling equations of indices, make sure that the bases are the same. This is a base. And I can write 8 in terms of 2. So this is going to be 2 to the power x is equals to, let me change the color so that you see the transformations. It means that here we will maintain the 1 over 8 can be written in terms of 2, which is 2 to the power 3, which is basically more like I'm making backwards, like from here to there. I don't know if people are related. Then let's try to finish it up here. This means that 2 to the power x, I know that the moment I remove a 1 here, what is just going to happen? I remove a 1, I'm going to come back to what? To a negative index, which is, sorry, let me just try to erase the 1. Oversight. All right, so this is going to be 2 to the power negative 3. Definitely, since now the bases are the same, and you have already interpreted this part to that, you can now just easily say my x is equals to what? It's equals to negative 3. Like that means that you are done. Like that. So it just requires you to just use a little bit of observation and see how things are going, and it's going to lead to a perfect understanding. All right, now how can we convert exponents to logarithms, and how can you convert logarithms to exponents? I think that will be the topic of the next video, and we're going to simplify logarithms, yeah, and do more actually. So now, if you want more information or if you want more videos, you can just easily drop your questions in the comment section. I'll be able to see them, and we're going to drop a video on it. But for now, those who want private tuitions, you can just contact the number 0970865597. If you want private tuitions, you can just contact this number and we're gonna handle it. This is your favorite tutor, Mr. Positivity. Just don't forget to subscribe and switch on, or just tap on that notification bell button so that you'll be notified each time we post a new video.